Today, I will discuss polynomials. Today, I will discuss polynomials. Already, you know that ninth class, we have studied polynomials in one variable and their degrees. Recall that if p of x is a polynomial in x, the highest power of x in p of x, that is called degree of the polynomial. That is degree of the polynomial. Here only is given as one variable is given, that is x, that is y, that is z, that is s, anything also. Only one variable. Total polynomial is written as one variable. Once you have to recall that p of x is a polynomial. Recall that p of x recall that p of x. Here see that. Recall that p of x is a polynomial in x, that highest power of x in p of x. P of x is the polynomial. That polynomial only for x. That polynomial only for x. That highest power of x, that is called degree of the, that is called degree of the, that is called degree of the polynomial. 4x plus 2. Here only degree is 1. 2y square minus 3y plus 4 is the polynomial. That degree is. Here see that 5x cube minus 4x square plus x minus root 2. Root 2 be a constant. Root 2 be a constant. But the highest power is 3. So degrees, so degrees 3. And 7 u power 6, 3 by 2 u power 4, 4 u square u minus. Here degrees, highest power of u, highest power of u, that is degrees, 6. That is degrees 6. Once you have to see that 1 by root x minus 1, there is no degree. There is no degree. Root x plus 2, that is also no degree. 1 by x square plus 2x plus 3, that is also no degree. This is not a polynomial because of these are totally these are not a polynomial. And this type of polynomial is not there. This type of polynomial is not there. And fraction values lo gaani, irrational numbers gaani unte avi polynomials kavu. Okay, next. A polynomial of degree 1, that is called linear polynomial. A polynomial of degree is 1, that is called a linear polynomial. That is called a linear polynomial. Degree 1 అయితే ఏమవుతుంది, linear polynomial అవుతుంది. And here 2x minus 3, that degree is 1. But through root 3x plus 5, x power degree is 1. Y plus root 2, y power degree is 1. X minus 2 by 11, x power degree is 1. 3z plus 4, z power degree is 1. 2 by 3 into u plus 1, u power degree is 1. These are called linear polynomials. These are called linear polynomials. The polynomial such 2x plus 5 minus x square. Here 2x plus 5 minus x square, x cube plus 1, etc. are not linear polynomials because of the degree is 1, that is called only linear polynomial. Degree is 1, that is called only linear polynomial. Okay, the highest power of x, is 1, that is called linear polynomial. And the secondary, a polynomial degree is 2. Polynomial degree is 2. That is called quadratic polynomial. And the highest power of degree, the x highest power of degree is 2. That is called quadratic polynomial. The name is quadratic, has been derived from the word quadrate, which means square. For example, 2x square plus 3x minus 2 by 5. Here degrees, highest power of degree. And here highest power of Here highest power of 2. Here highest power of 2. Here highest power of 2. Are some examples of quadratic polynomial whose coefficient are real numbers. Whose coefficient of real. More generally, any quadratic polynomial in x is of the form ax square bx bx plus c. That is the general form of the quadratic polynomial. That is the general form of the quadratic polynomial. General form of the quadratic polynomial, where a, b, c are real numbers and a is non-zero element. Because of, for suppose a is equal to 0, for suppose here ax square plus bx plus c is equal to 0, where a is equal to 0, this implies 0 into x square plus bx plus c is equal to 0. 0 into x square means 0x, bx plus c is equal to 0. Here x power 1. Here the highest power of x is 1. So this is linear polynomial, not a quadratic polynomial, not a quadratic polynomial, not a quadratic polynomial. So a is compulsory not equal to 0. Okay. And second, more generally, in any quadratic polynomial, x is of the form ax square plus bx plus c, where a, b, c are real numbers, a not equal to 0. A polynomial degree 3, that is cubic polynomial. That is cubic. For suppose that examples is cubic polynomials are 2 minus x cube. Here x power 3, here x power 3, here x power 3, here x power 3, here x power 3. So the highest power of x is 3. The highest power of x is 3. So that is most general form of the cubic polynomial. The highest power of x is 3. That is a cubic polynomial. Cubic polynomial general formula is ax cube plus bx square plus cx plus t. The highest power of x is 3. Highest power of x is 3. Here a, b, c, d are real numbers, but clearly a is not equal to 0. A is not equal to 0. For suppose a is equal to 0 is there. For suppose a is equal to 0, that means of 0 into x cube plus bx square plus cx plus d. It implies bx square plus cx plus d. So highest power of x is 2. So this is not a cubic polynomial. This is not a cubic polynomial. So compulsory a is not equal to 0. This is mentioned. Now consider the polynomial p of x is equal to x square minus 3x minus 3, x square minus 3x minus 3, and that is quadratic polynomial. Then putting x is equal to 2. Then putting x is equal to 2. X square minus 3x minus 4. X square minus 3x minus 4. X square minus 3x minus 4. X is equal to 2. This implies p of 2 is equal to 2 square minus 3 into 2 minus 4. This is equal 4 minus 6 minus 4. This is equal minus 6 minus 6. That value. Therefore, p of 2 is equal to 6. P of 2 is equal to x is equal to 2 square 4 minus 2 minus 3. Next, for suppose similarly, is the value of x square minus 3x minus 4 at x is equal to, similarly p of 0 is the value of p of 0. Again, we have to take x square minus 3x minus 4. That is equal to p of x. Putting x is equal to 0. This implies p of 0 is equal to 0 square minus 3 of 0 minus 4. This is equal to 0 minus 0 minus 4. This is equal to minus 4. Therefore, p of 0 is equal to minus 4. P of 0 is equal to minus. Okay. If p of x is a polynomial in x, if k is any real number, then the value obtained by replacing x by k in p of x, that is called p of x at x is equal to k, and we denoted by p of k, p of k. The value of p of x is equal to k, and we denoted by p of k. Therefore, p of x is equal to x square minus 3x minus 4 at x is equal to minus 1. We have p of minus 1 is equal. Once again, we have x square minus 3x minus 4. X square minus 3x minus 4. Put x is equal to minus 1. Put x is equal to minus 1. X square minus 3x minus 4. Putting x is equal to minus 1. P of minus 1 is equal to minus 1 whole square. 3 of minus 1 minus 4. This is equal to 1 plus 3 minus 4. This is equal to 4 minus 4. This is equal to minus 1. P of minus 1 is equal to minus 1 whole square minus 3 of minus 1 minus 4. Minus 1 whole square means 1. 3 of minus 1 is equal to minus of minus plus 3 into 1 is equal to 3. That is minus 4. 4 minus 4 is equal to 0. 4 minus 1, 4 is equal to 0. Therefore, P of minus 1 value is 0. P of minus 1 value is 0. Okay. Next, also note that P of 4. Also note that P of 4. Once again, x square minus 3x minus 4. X square minus 3x minus 4. X square minus 3x minus 4. X square. P of x is equal to P of x is equal to x square minus 3x minus 4. Putting x is equal to minus 4. That implies P of minus 4 is equal to minus 4 whole square. 3 into minus 4 minus 4. This is equal to minus 4 whole square means 16. Minus of minus plus 12 minus 4. 16 plus 12, 28 minus 4. This is equal to 24. P of minus 4 is equal to 24. P of minus 4 is equal to 24. For suppose, same as this. Again, P of x is equal to x square minus 3x minus 4. Putting x is equal to 4. Therefore, P of 4 is equal to 4 square minus 3 into 4 minus 4 is equal to 16 minus 12 minus 4. 16 minus 16. This is equal to 0. Into P of 4 is equal to 0. Last time, P of minus 4 is equal to 24. P of minus 4 is equal to 24. P of 4 is equal to 0. Okay. P of minus 1 is equal to 0. P of 4 is equal to 0. Minus 1 and 4 are zeros of the quadratic polynomial. Minus 1 and 4 are zeros of the quadratic polynomial. See that here. See that? P of minus 1 is equal to 0. P of 4 is equal to 0. And the minus 1, 4 are called zeros of the quadratic polynomial. అంటే జీరోస్ ఆఫ్ ద క్వాడ్రాటిక్ పాలినామియల్స్ మనం ఏమంటాం అంటే రూట్స్ అని కూడా అంటాం. జీరోస్ ఆఫ్ ఏ క్వాడ్రాటిక్ పాలినామియల్ మనం ఏమంటాం రూట్స్ అని కూడా మనం చెప్పుకుంటూ వస్తాం. రూట్స్ అని కూడా మనం చెప్పుకుంటూ వస్తాం. అవి ఏవైతే పి ఆఫ్ ఎక్స్ ఈజ్ ఈక్వల్ టు జీరో వేర్ పి ఆఫ్ కే ఈజ్ ఈక్వల్ టు జీరో, పి ఆఫ్ ఎక్స్ ఈజ్ ఈక్వల్ టు జీరో వేర్ పి ఆఫ్ కే ఈజ్ ఈక్వల్ టు జీరో అవుతాయో వాటిల్లో మనం ఏమంటాం అంటే రూట్స్ అని చెప్తుంది. దాన్నే పోలినామియల్ తాలూకా జీరోస్ పోలినామియల్ అంటారు. దాన్ని ఏమంటాం జీరోస్ పోలినామియల్ అంటారు. ఫర్ సపోజ్ P of x is equal to 0, that is the linear polynomial. P of x is equal to 2x plus 3, that is the linear polynomial. P of x is equal to 2x plus 3, that is the linear polynomial. Already you are studied in 9th class. Find the zeros of the linear polynomial. Find the zeros of the linear polynomial. P of x is equal to and the linear polynomial of the zeros. Linear polynomial of the zeros. 2x plus 3. 2x plus 3. P of x is equal to 2x plus 3. Directly we want to find out the zeros of the polynomial. Okay, zeros of the polynomial. Zeros of the polynomial means immediately P of x is equal to 0. P of x means 2x plus 3 is equal to 0. Therefore 2x is equal to minus 3. X is equal to minus 3 by 2. This is the zeros of the polynomial x value. This is the zeros of the polynomial x is equal to 0. Okay, P of minus 3 by 2 is equal to 0. P of minus 3 by 2 is equal to 0. Therefore, x value is, and the P of x is equal to 0 means x is equal to minus 3 by 2. This is the zeros of the polynomial. This is the zeros of the polynomial. Okay. So, similarly, the general form of for suppose P of x is equal to ax plus b. P of x is equal to ax plus b. Find 0 of the polynomial P of x. Then P of x is equal to 0. That means of ax plus b is equal to 0. Therefore, x is equal to minus b by x is equal to minus b by a. X is equal to minimum. Therefore, P of minus b by a is equal to 0. Minus b by a is equal to 0. This is the general formula. This is the general formula. This is the general formula of ax plus b is equal to 0. 2x plus 3. Then P of k is equal to 0. It gives the 2k plus 3 is equal to 0. K is equal to minus 3 by 2. K is equal to minus 3 by k is equal to minus 3. In general, k is a 0 of the P of x, then ax plus b. P of x, k is equal to ak plus b. That is k is equal to minus b by a. And here clearly x is equal to. Yeah, before time I taken as variable x. Here I taken as k. So the zeros of the linear polynomial ax plus b is minus b by a. And the constant term by coefficient of x minus constant term coefficient of x. The zero of a linear polynomial is related to its coefficient. Does this happen in the case of other polynomials is true? For example, are the zeros of the quadratic polynomial also related to coefficients? In this chapter, we will try answer these questions. We will also study the division algorithm polynomials. Okay, geometrical meaning of zero polynomial. Geometric meaning of zero polynomial. You know that real number k is a zero of the polynomial p of x if p of k is equal to 0. But why Are zeros of a polynomial so important? To answer this, first we will see the geometrical representation of linear quadratic polynomials and the geometrical meaning their zeros. See that here. Consider the first linear polynomial ax plus b, where a not equal to 0. We have studied the class 9th class. Y is equal to x plus b. This is the straight line of the equation. This is the straight line of the graph. And y is equal to ax plus b. Every linear equation can be draw a graph that is clearly straight line. That is clearly straight line. And a linear polynomial, anything also in a, you can draw the diagram of the graph clearly line, clearly straight line. For example, graph y is equal to x plus 3. Line is passing through the points -2 and -1 and 2, 7. 2, 7. And for suppose x is equal to here x value and y value you have to find out. X value, y value you have to find out. Y is equal to 2x plus 3. Y is equal to 2x plus 3. Is line passing through -2, -1, 2, 7. -2, here, see that. -2, 7, -2, -1. Here -2, -1, and 2, 7. -2, -1, and 2, 7. X is equal to -2, y is equal to -1, x is equal to 2, and y is equal to 7. Before time, I substitute the x value. X value -2 is 2 into -2. 2 into -2, -4. -4 plus 3 is -1. Other x is equal to 2. 2 is 4 plus 3 is 7. Y is equal to 7. And the first coordinate is x and the second coordinate is y. First coordinate is x and second coordinate is y. From figure 2.1, this is the figure. You can see that the graph y is equal to x plus 3 intersect the x-axis midway between the x is equal to -1 and x is equal to -2. That is at the point clearly 3/2 comma 0, 0 comma 3. 3/2 -3/2 comma 0, 0 comma 3. And both points are intersect the x-axis and intersect the y-axis. Intersect the y-axis means 0 comma 3. Intersect the x-axis -3/2 comma 0. You also know that 0 of the polynomial 2x plus 3 is -3/2. Is -3/2. Thus, the 0 of the polynomial 2x plus 3 is the x coordinate of the point where the graph of y is equal to 2x plus 3 intersects the x-axis, అంటే x-axis ని ఏ పాయింట్ వద్ద అయితే ఇంటర్సెక్ట్ చేస్తుందో, x-axis ని ఏ పాయింట్ వద్ద అయితే ఇంటర్సెక్ట్ చేస్తుందో, అంటే x-axis ని ఏ పాయింట్ వద్ద అయితే ఇంటర్సెక్ట్ చేస్తుందో, దట్ point is the zero of the polynomial. That point is the zero of the polynomial. If you are taken the point of x-axis, if the taken the point, any point intersect the x-axis, that point is called a zero of the polynomial. That point is called a zero of the polynomial. ఆ పాయింట్ నే మనం అంటే x-axis ని ఏ పాయింట్ వద్ద అయితే ఆ లైన్ అంటే నీవు తీసుకున్న లైన్, ఇఫ్ యు ఆర్ టేకెన్ ద లైన్, ద స్ట్రైట్ లైన్ intersect the x-axis, that point is called zero of the polynomial. x-axis ని ఏ పాయింట్ వద్ద, స్ట్రైట్ లైన్ x-axis ని ఏ పాయింట్ వద్ద అయితే ఇంటర్సెక్ట్ చేస్తుందో ఆ పాయింట్ మాత్రమే జీరో ఆఫ్ ద polynomial. y-axis కాదు, y-axis ని ఇంటర్సెక్ట్ చేసిన పాయింట్ మనకి జీరో ఆఫ్ ద polynomial కాదు. x-axis ని మాత్రమే ఇంటర్సెక్ట్ చేసిన పాయింట్ జీరో ఆఫ్ ద polynomial. And here see that in general the linear polynomial x plus b where a not equal to 0, the graph y is equal to x plus b, the straight line which intersect x-axis, it is clearly minus b by a comma 0. Therefore the linear polynomial ax plus b where a not equal to 0 is exactly 1 0 అంటే ఇక్కడ లీనియర్ పోలినామియల్ కాబట్టి ఓన్లీ దిస్ ఇస్ ద లీనియర్ పోలినామియల్ కాబట్టి జీరో కూడా ఒకటే జీరో ఉంటుంది అంటే జీరో ఆఫ్ ద పోలినామియల్ అంటే దాన్ని రూట్స్ ఆఫ్ ద పోలినామియల్ x coordinate of the point where the graph y is equal to x plus b that intersect the x-axis. Now let us look at the geometrical meaning of a zero of the quadratic polynomial. Consider quadratic polynomial x square minus 3x minus 4. It is clearly y is equal to x square minus 3x minus 4 look like, let us list a few values. Y is equal to x square minus 3x minus 4 corresponding to few values of for x is given table 2.1. X is equal to minus 2 minus 1 0 1 2 3 4 5 in a graph. గ్రాఫ్ లో మనం ఉపయోగించేటప్పుడు గ్రాఫ్ లో మనం తీసుకునేటప్పుడు x ఈజ్ ఈక్వల్ టు -2 -1 0 1 2 3 4 అంటే ఇది క్వాడ్రాటిక్ పోలినామియల్ లో ఖచ్చితంగా ఎన్ని రూట్స్ వస్తాయి మనకి highest పవర్ 2 ఉంది కాబట్టి 2 zeros of the polynomials 2 zeros of the polynomial 2 zeros of the polynomial. Here clearly you have to see that x is equal to -2 x is equal to -2 x is equal to -2 means -2 whole square 4 plus 4 minus 4 cancel -2 minus 2 means +6. Here see that -1 here see that 0 here see that 0 and y value is -4 x value is 1 and y value is -6 x value is 2 x value is 2 y value is -6 x value is 3 and y value is -4 x value is 4 and y value is 0 x value is 5 and y value is 6. That's the point. First -2 plus 6 -1 0 0 -4 1 -6 2 -6 3 -4 4 0 5 6. If you look at the point listed about the graph paper in rather, we actually look this one given figure. In fact, of quadratic polynomial ax squared plus bx plus c a not equal to 0, the graph of corresponding equation ax squared plus bx plus c has one of the two shapes, either open upwards like or open downwards like, depending whether a greater than 0 and a less than 0. These curves are called parabolas. These curves are called parabola. These curves are called parabolas. These curves are called parabolas. You can see that. You can see the table 2.1. That -1 and 4 are clearly you have to see that. This is the point. And this one is the point. This is the this one. This is the 0 of the point. This is the 0 of the polynomial. This one is the 0 of the point. And the -1 and 4 is the 0 of the polynomial above quadratic polynomial. But clearly this is parabola. This is parabola. You can see that -1 and 4 are zeros of the polynomial. -1 and 0 of the polynomial, quadratic one. Also note that in figure 2.2, -1 and 4. -1 and 4, 0 of the quadratic polynomial. Also 2.2, -1 and 4, the coordinates of the where the graph y is equal to x square minus 3x minus 5 intersect the x-axis. X-axis ni ఏ పాయింట్ వద్ద అయితే ఇంటర్సెక్ట్ చేసిందో ఆ పాయింట్స్ మాత్రమే క్వాడ్రాటిక్ పోలినామియల్ తాలూకా 0 ఆఫ్ ద పోలినామియల్. x-axis ని ఏ పాయింట్ వద్ద అయితే ఇంటర్సెక్ట్ చేసిందో ఆ పాయింట్ వద్ద మాత్రమే ఎక్స్ యాక్సిస్ని ఏ పాయింట్ వద్ద అయితే ఇంటర్సెక్ట్ చేసిందో ఆ పాయింట్స్ మాత్రమే క్వాడ్రాటిక్ పోలినామియల్ తాలూకా జీరో ఆఫ్ ద పోలినామియల్. హియర్ క్లియర్లీ -1, 0, 4, 0 పాయింట్స్ వద్ద ఇంటర్సెక్ట్ చేసింది కాబట్టి x coordinates -1 and x coordinates 4, both points are zeros of the polynomial by above quadratic equation. That quadratic equation is x square minus 3x minus 4. The quadratic polynomial p of x is equal to x square minus 3x minus 4. The zeros of the polynomial -1, 4. This is find the graph. అంటే గ్రాఫ్ ద్వారా మనం జీరోస్ ఆఫ్ ద పోలినామియల్ ఫైండ్ అవుట్ చేయడానికి ఈ విధంగా మనం యూజ్ చేసుకుంటూ ఉంటాం. ఓకే, దిస్ ఫ్యాక్ట్ ఈస్ ట్రూ ఫర్ క్వాడ్రాటిక్ polynomial, that is the zeros of the polynomial ax square plus bx plus c a not equal to 0. Precisely the x coordinates of the point where the parabola representing y is equal to x square plus bx plus c intersects x-axis. Which is very important. This fact is true for any quadratic polynomial, that is the zero of the quadratic polynomial ax square plus bx plus c a not equal to 0 is precisely x coordinates of the points where the parabola representing y is equal to ax square plus bx plus c that intersect x-axis. That points is called that points is called that is -1, 0, 4, 0. That is -1, 0, 4, 0. Okay. From our observation earlier about the shape of the graph, that is following case can happen. Okay. Next case 2. Here the graph cuts x-axis two distinct points A and A dash. The x coordinates of A and A dash, the two zeros of the quadratic polynomial ax square plus bx plus. This is also this point. This is the one of the point. This is the one of the point. This is the one of the point. This is the one. That is the zero of the parabola. That is the zero of the parabola. This is the open parabola. That is here. See that two shapes either open upwards like open upwards like down upwards like, depending upon the parabolas. These are curves are called parabolas. Open upwards like, down upwards like. This is down upwards like. This is the open upwards like parabola. Down upwards like parabola. Case 2. Here the graph cuts the x-axis at exactly one point. That is two coincident points. So the 2 points A and A dash, the coincident here become a point. See that here? This is. Both coincidents means zeros are equal. Zeros are two zeros there. Two zeros are equal. Two zeros are equal. Two zeros are equal. Two zeros are equal. The x coordinates of A is the only zero of the quadratic polynomial ax square plus bx plus c in this case. Okay. Next, there is no roots. Here there is no intersect of the x-axis, so there is no roots here. No zeros, of the polynomial because of that is not intersect in x-axis, not intersecting x-axis, not intersecting x-axis. This is also here. No, no zeros. Here also no zeros because of not intersect in x-axis. This is also not intersect in x-axis. Okay. So the quadratic polynomial ax square plus bx plus c has no zeros. The quadratic polynomial ax square plus bx plus c, no zeros in this case. So you can see geometrically quadratic polynomial can have the two zeros. You can see geometrical quadratic polynomial can have the either two distinct zeros of two equal zeros, 1 0 or no zero. This also means that a polynomial of a degree 2 has at most two zeros, at most two zeros, at most two zeros. Okay. Now, what do you expect the geometrical meaning of zeros of the cubic polynomial is? It is 3. It is clearly, it is clearly clearly 0. 1, the 1, this is the 2, this is the 3 zeros. Clearly 3 zeros. 3. Okay. Are you able to understand? Any more doubts? This is the cubic polynomial. This is the cubic polynomial. See the table. Let us few more examples consider the cubic polynomials x cube minus x square. We would rather graph y is equal to x cube and y is equal to x cube minus x square. Y is equal to x cube minus x square. Clearly, this is the x cube minus 4x, x cube minus 4x. This is x cube. This is x cube minus x square. X cube minus x square. 1, 2. Here 1. Object. Note that 0 is the only zero of the polynomial x cube. Note that 0 is the only zero of the polynomial. Also figure 2.7 you can see that. 2.7 you can see that. Only 0 is the polynomial of the 0. 0 is the polynomial of 0, 0, 0. Okay. And x coordinates of only point where the graph y is equal to x cube. Where the point y is equal to x cube. They intersect the x-axis. Similarly, since x cube minus x square is equal to x square into x minus 1, 0 and 1 are the only zeros of the polynomial, only zeros of the polynomial x cube minus x. Also 2.8. These values of x coordinates, so 0 and 1, 0 and 1, 0 and 1. Okay. Okay. Intersect the x-axis. From the examples above, see the three or at most three zeros for any cubic polynomial. In other words, any polynomial of degree can have at most three zeros. In general, given polynomial p of x of degree n, the graph of y p of x intersect the x-axis at most n points. Therefore, the polynomial p of x degree n has at most n zeros. At most n zeros. For example, here 1, here 1, 2, here 1, 2, 3. Okay. This is having only one zero of the polynomial. This is two zeros of the polynomial. This is one zero of the polynomial. This is two zero of the polynomial. This is three zero of the polynomial. This is one zero of the polynomial. This is one zero of the polynomial. This is one, two, three zero of the polynomial. Three zero of the polynomial. Okay. Solution. The number of zeros 1. The graph of intersects. The number of zeros 2. Graph of intersects 2 point. Number of zeros is 3. Okay. Again, here see that there is no zeros. There only one zero. See that? No zeros. Here, 1 0. Here, 1, 2, 3. Here, 1, 1, 2, 3. Here, 1. Okay. That is the zeros. That is the zeros. Relationship between zeros and coefficient of the polynomial. Zeros and coefficient of the polynomial.